In Module 4, Lesson 26, we're going to start with one-step equations where we add and subtract. So we're going to start by solving these equations by using tape diagrams and algebraic methods for each problem. And we'll use substitution to check our answers. So when we look at b plus 9 being equal to 15, here's what we want to draw. So we see two tape diagrams, the first one showing one side of our equal sign and the other one showing the other side. Our first one, b plus 9, and our second one, 15. Hopefully we can see then that what we should be doing is subtracting 9 from 15, and that will tell us how much b is. So b equals 6. In our second problem, we have 12 equals 8 plus c, so we'll draw the diagram. And then we see that if we want to find out how much c is, we can subtract 8 from 12, and c equals 4. Now in exercise 2, we're starting with the variable. We don't have the variable that we're subtracting or adding. So we're going to draw the tape diagrams, and then we'll see what that looks like as well. So when we look at our tape diagrams, we'll notice the whole tape diagram is D. And if we take 5 away from D, we end up with 7. So that should help us to determine that D must be 5 plus 7, or 7 plus 5, which is 12. Hopefully we're starting to see that we're doing the opposite of what's being done in the problem. So we're adding 5 to find out what D is. In our early problems, we were subtracting. To solve the equation algebraically, we take the problem D minus 5 equals 7. And then what we'll do is add 5 to each side of the equation, because if we add it on both sides, it's still balanced. And minus 5 plus 5 is going to leave us with D. So D is equal to 12. Remember, minus 5 plus 5 was 0, and that was way back in the early part of our module. And D minus 0 is D, so D is equal to 7 plus 5. Then what we'll do is substitute 12 into our original equation. We have 12 minus 5 equals 7. And if that is true, which it is, then we know that we found the correct answer. Exercise 3, we're asked to solve each problem and show our work. And we can choose which method, tape diagram or algebraically, that we prefer. Remember to check our answers after we solve each problem. So I will solve them algebraically. But you are certainly welcome to draw your own tape diagrams. Algebraically, I would subtract 12 from both sides because it's being added. So I'll do the opposite. And then on the left side, plus 12 minus 12 would give me 0. And E plus 0 is E. And 20 minus 12 is 8. To check whether that's correct or not, I will substitute 8 for E in our original problem. And 8 plus 12 is 20. 20 equals 20, so we know that we've solved it correctly. In our second problem, we have f minus 10 equals 15. So I'm going to do the opposite of subtracting 10, and I'll add 10. Remember, that's because we will end up with 0, f minus 0, on the left side of the equation. So f minus 10 plus 10 equals 15 plus 10. We have to do exactly the same thing on the right side as we do on the left side. On the left, we'll end up with f, and on the right, we will have 25. So f is equal to 25. Let's substitute into the original equation to see if that is true or not. 25 minus 10 is 15, and 15 is equal to 15. And then in C, again, we have g minus 8 equals 9. So I'm going to add 8, the opposite of subtracting it. And I have to do it to both sides. We know then that g plus 0 is g, and 9 plus 8 is 17. Finally, we'll substitute 17 into the original equation and see if that is true or not. 17 minus 8 is 9, and 9 is equal to 9.